So this is chapter 1 review, problem 14. We did the question A, where it was asking if 2 liters of fat is removed and you're given the density, what is the mass in kilograms of this fat? So we answered that question. And now we need to answer question B. That is asking how many pounds of fat have been removed. So this is a simple conversion because it's only, so from kilograms, you want to find pounds. So you want to look at your reference packet for unit 1. And let me actually share that. So this is the reference packet I would like you to have printed if you are able to print. And so the question is asking to convert kilograms to pound. So let's see if we have a direct relationship between kilogram and pound. So kilograms and pounds are units of mass. So you will want to look at the lines where you have mass there. Kilograms are are a metric unit, and pounds are English or US system. And so here, if we look at mass, we want to look at the third column because it's between metric and US. And there is a conversion between kilogram and pound here. It says 1 kilogram is 2.205 pound. So let's copy that in our chapter 1 review. So I'll go back to chapter 1. Chapter 1 review. And we found the equality 1 kilogram equals 2.205 pound. So that's the equality we will use. First, actually, we should have thought about what is the given amount. So how many pounds of fat have been removed, given that you just calculated what was the mass in kilogram, your given will be the answer to the previous question, and it's the 1.9 kilogram of fat. And so that's the given, and we want to change that into pound. So the roadmap looks like this. You start with, let me insert the equation there. You start with kilograms, and you want to change that into pound. And we have a direct relationship between kilograms and pounds, so we can do it directly using this equality. That's an equality. And out of an equality, we can write 2 conversion factors. So the calculation always starts with the given amount. So when you write your, when you're ready to write your calculation, your full calculation, you always want to start with the given amount. And the given amount is in the numerator. So we have 1.9 kilogram, and we want to change that to pound. So we want to cancel the kilograms that are in the numerator here with kilograms in the denominator. So the equality will be written such that the 1 kilogram will be on the bottom. So we cancel the kilograms. And then on top, we will write the 2.205 pound. And here, there's no need to add another conversion factor. That's already the unit we want. Yeah, by the way, here, what you want is pounds. So in the calculator, you do 1.9 times 2.205 and it's a 4.1895. I write everything that comes in from the calculator. And the unit here is pound because the kilograms have cancelled. So we're left with pound. Now you need to run this properly. And so you look at your given measurement. 1.9 has 2 sig figs. 1 kilogram here, 1 kilogram equals 2.205 pound. It's an equality. And so the 1 kilogram is exact. You took 1 kilogram exactly, and then the 2.205 pound was measured. So this is measured, so we need to count the number of sig figs from this, and we have 4 sig figs in 2.205. 4 sig figs versus 2 sig figs from the 1.9, that means we have at least, the least number of sig figs is 2. So we will need to round to 2 sig figs, and so here we will have to do 4 point, and then we keep the 1, but what comes after the 1 is an 8. So you need to round up. So the 1 will become a 2, and then pound. And so that would be the full answer for question B. So, sorry. Sorry if it's loud. Okay, so you always start the calculation by writing down the given amount. And the given amount usually is a simple measurement with a single unit, like here 1.9 kilograms. And it will be written in the numerator. Even though here it shows like it's in between, it is in the numerator. You could write, draw a line under and have a 1 in the denominator to show that the 1.9 kilogram is in the numerator. And so, so this first given measurement is key to know what comes next, because it has a unit and you want to cancel that unit because you want to change it to another unit. So you want to cancel it, and to be able to cancel it, you need the same unit in the denominator of the conversion factor that comes next. So then you want to have kilograms in the denominator of the conversion factor such that kilograms will cancel, just the units, kilograms. The numbers stay, it's just the unit that cancel. Because, but mathematically, when you have, something over the same thing, it's equal to 1. So they cancel, and then it's equal to 1, which doesn't need to be shown there. And so that conversion factor, the ratio of 2.205 pound over 1 kilogram, it's a conversion factor because 1 kilogram is equal to 2.205 pound exactly. So because these two quantities are the same, so this ratio is like 1 because they cancel out because it's the same quantities. So multiplying by a conversion factor is like multiplying by 1. And it only changes the unit of your measurement to another unit. So of course the number will be different because the unit is different. So the number will be different. And so here in this case, kilograms cancel and you're left with pound, which is the desired unit. And so you multiply 1.9 by 2.205 pound to get the final answer. I don't know if this was helpful. Okay. Okay. So let's try to do the problem 15 to practice this more. So a patient receives an intravenous solution we call intravenous IV, the I for intra, V for venous. So IV solution that flows at the rate of 150 milliliters per hour. So when you see that 150 milliliters per hour, you have to tell yourself that's a conversion factor, because the per hour tells you that you can rewrite this. And let's rewrite this. You can rewrite it as an equality that says 150 milliliters is equal to an hour. You can write it like this mathematically, right? That's what it means. You get 150 milliliters over the course of an hour. So that's the rate of the IV. So how much fluid does the patient receives in 20 minutes? And here 20 as a dot here to show that the 0 is significant, right? So you want to keep that. So let's do the first question first, right? You don't want to read the rest for now. So A. So how much fluid does the patient receive in 20 minutes? So we know that the 150 milliliters per hour is going to be our conversion factor most likely, because it's you know, an equality. And here we have 20 minutes. So 20 minutes is you're given 20 minutes. And you want to know how much fluid did you receive in those 20 minutes. So want how much fluid. So I will write this, how much fluid, but you have to guess what will be the unit. What do you think? Because the rate is given in milliliters per hour, so then that means you can expect that the fluid will be given in a volume, so as a volume in milliliters, because that's the information you have. So then you want to match that. So how much fluid as a volume in milliliters? So we know the given amount, we have our equality, and what we want also has a unit that comes from this equality, right? Milliliters. So we have everything, looks like, well, no, minutes versus hour. We are missing something here, right? You cannot cancel minutes with hour. You have to give the equality that relates an hour to a minute, 2 minutes. So we know that in an hour we have 60 minutes, and that will allow us to change hours to minutes. So we will need 2 conversion factors. So to see this more clearly, let's write the roadmap. I really like to use roadmaps. I think that they're really helpful. So you want to start by the given unit, and here the given is minutes. Minutes that you will want to change into. So from minutes you can go to hour, right? From minutes you cannot go directly to milliliters. So you will have to change those minutes into hours. Next, once you have the hours, you have a conversion now that tells you can change those hours to milliliters. So then from hours, we will be able to go to milliliters of fluid. So that means we will have 2 conversion factors. Those 2 arrows, they correspond to 2 conversion factors. So that's our roadmap. And let me push it so we see that better. Okay. So now we are ready to start our calculation, and you always start your calculation by writing first the given amount, the 20 minutes here. So 20 minutes is our given amount. It's in the numerator, right? And you will multiply by a conversion factor. A conversion factor is a fraction. And so here, because we start with minutes, and we need to change that to hours according to our roadmap. So we will need to use the conversion factors that relates hours to minutes. And so the 1 hour equals 60 minutes is the conversion factor you will use first. So minutes in the given amount here is the unit you want to cancel with the first conversion factor. So the denominator of your conversion factor will have to have minutes. So the 60 minutes will have to be on the bottom. And then the 1 hour will have to be on top. Right, because they go together. 1 hour equals 60 minutes. And this way the minutes cancel. I cannot show that on the computer here, but imagine that you draw a line through minutes and 20 minutes, just the minutes, and minutes in the denominator. So we have hours. If we calculated the answer now, we would have a number of hours. Now, the second conversion factor will want to cancel those hours because that's not the ultimate, measurement we want. We don't want to know, how many hours there is in 20 minutes. What we want is how many milliliters. And so you will use the equality that relates the hour to the milliliters, and you will want to cancel hours. So the next conversion factor needs to have the hours on the bottom. And so from the equality 1 hour equals 150 milliliters, you will want to put the 1 hour on the bottom and the 150 milliliters on top. And so here you can see that minutes cancel, numerator, denominator, and hours cancel, one in the numerator and the other in the denominator. And we are left with milliliters. So we know the answer of this calculation will be milliliters. So let's do the calculation. In your calculator, 20 is in the numerator. So you multiply it by an hour, so you don't have to do this, divided by 60. So divide by 60. And then you need to multiply by 150. And the order in which you do that doesn't matter. So 20 multiplied by 150 divided by 60, and that's equal to 50. So 50 milliliters. You need to pay attention to suffix. And here, let me add a dot here that we know that there is exactly 60 minutes in an hour, right? So that's why I want to put the dot here to show it's exactly 60 minutes, not, plus or minus 1 on that 0. So 1 hour is exact, 60 minutes are exact because it's exactly 60 minutes in an hour. The other hour is exact, and the 150 meters are measured, right? It's a flow rate that is measured. And in 150 like this, there is only 2 sig figs because the 0 is not significant. And our given amount of 20 minutes, because of the dot, the 0 is significant. And so that's also 2 sig figs. So we have 2 sig figs, both for 20 minutes and 150 meters. So we need to keep 2 sig figs at the end. And right now, how many sig figs do I have in 50 meters? I have only 1, right? So to show that I have 2 sig figs, I need to show the dot there, right? Yes. I need to show the dot to show that it's 2 sig figs. So it's 50 exactly, well, not exactly, but at 2 sig figs. And that would be the amount of milliliters that the patient received in 20 minutes. Do you have questions? So what is the question? How long does it take for the patient to receive 90 milliliters of fluid? So how long does it take for the patient to receive 90 milliliters of fluid? So here, what we want, sorry, it's easier for me to start with what we want. than the given here. What we want is how long does it take? So how long? So it's you know, how much time, right? So we'll see what is the unit of that. How long does it take for the patient to receive 90 milliliters of fluid? So the given here is the 90 milliliters, right? There is no other measurement given. So you can bet that the 90 milliliters are the measurement, the given. You will start with that and you will calculate how long it takes to receive that amount. So how long does it take to receive that? Given that the equality will be again using the fact that you get 150 milliliters in an hour. So it could be the time, how long could be an hour? Or it could be minutes again, because it's, you see that 90 milliliters is less than 150 milliliters in an hour. So it's probably better to answer in minutes. How long in minutes? So that means we will need to convert 60 minutes into an hour. Does it make sense? So yeah, this problem is a bit more tricky because it doesn't give you the units you need to give your answers with. So it's up to you to find out from what is given, the information that is given, to find out, you know, what would be the units, desired units. So let's look at the roadmap here. So we start with milliliters that we want to know how long it takes to deliver. So we start with milliliters. We will again use the flow rate to calculate hours, you know, how it took, because we have the equality between milliliters and hour. So we have to change those milliliters to hour. And then because it's not going to be a full hour, then it's easier to have this back into minutes. Right? So then you start your calculation, and the calculation, you always want to start it with the given amount, and here it's 90 with a dot milliliters that we want to deliver, and we want to know how much time. And you will multiply by the conversion factor that relates milliliters to hour, right? Because according to the roadmap, that's what we can do. We have an equality between milliliters and hour. So we will use 150 milliliters per hour. And because you want to cancel milliliters from the given amount here, so you will want to place 150 milliliters on the bottom and an hour on top. Because we want this in minutes, we can multiply now by the next conversion factor that gives, so an hour will be on the bottom because we want to cancel with the hour that is in the numerator, and 60 minutes will be on top. And this way we will know how many minutes are required to deliver 90 milliliters. So you do 90 milliliters divided by 150 and multiply by 60. And it's 36 minutes. So here again, 1 hour each time, those 1 hours are exact. The 60 minutes, I can put the dot here because that's exactly 60 minutes in an hour by definition, right? And 150 again is measured, has 2 sig figs. 90 with the dot here has 2 sig figs, so we keep 2 sig figs at the end.